record. Okay, so when we are talking about seasons again, we actually notice that our revolution around the sun is not, it doesn't have the sun directly in the center. So we're actually further away at one point and closer in another. But because of that tilt, even though we're further away, north hemisphere, gosh darn it, the northern hemisphere, because it's tilted towards the sun, it's in summer. The southern hemisphere would be in winter in this position. And then on the other half of the revolution, it's northern hemisphere's winter because we're tilted away. Okay, so again, we have 4 seasons, and it's all because of the tilt of our Earth. Okay, so as it rotates, we get that direct sunlight here, giving one half of the planet, either the northern or southern hemisphere, the direct sunlight versus the other way. Okay. Questions on this? When you're ready, go ahead and click go faster. Thank you, Robert. This is the perfect time for me to bring solstice up. Now, if we notice, I'm going to go back a slide though. No, this is good. Okay, so notice here the northern hemisphere is tilted towards the sun. So the top half of the planet is in summer. Okay, that means that the southern hemisphere, the bottom half of our planet, is tilted away and now it's winter. Now, we have summer solstice and we have winter solstice. And these are going to be the extremes of our seasons. So during summer solstice on June 21st, we have actually the longest day of the year. That's when we have the most sunlight ever. And then in the winter solstice on December 21st, we actually have the shortest day of the year, the least amount of sunlight. Now, these people that are living at the actual poles, on solstice, they have extremes of this, meaning if you're at the North Pole during this position and you're still rotating around, right? But at the North Pole during June 21st, I think it lasts about 36 hours, the sun never sets. So imagine instead of the sun going up and then going down, that the sun does a little like loopy circle above your head. That's what's happening here at the North Pole. And at the same time, at the South Pole, we have the winter solstice happening down here. They get no sun at all for about 36 hours. So that many studies have been done on these population of people, because that messes up your mind. It like messes you up, because we have this internal clock. You know how we just did we set our clocks back an hour, and now it feels like midnight and it's only like 7 o'clock, and you're like, what the heck, right? And so imagine the sun never going down and the sun never coming up at the extremes during the solstice. So kind of cool. Usually during that time of the year, people who live in these areas will move a little bit closer, will take a little vacation closer to the equator, so they're not affected so much. Okay. All right. Other questions? Robert, I hope that answers your question. Okay. So then we have Bill Nye. Mr. Bill Nye is actually going to recap in case you don't quite understand, and then let me know. Let me change how I'm sharing.
The seasons.
And because I'm going to go full screen, new share. the whole thing. All right, here we go.
It gets cold in the winter. Flowers bloom in the spring. We get lots of sun in the summer. And leaves fall in the fall. See, the Earth's seasons affect every living thing on Earth. That's right. Seasons affect the way everything grows and changes every year. The reason we have seasons on Earth is because the Earth is tilted. Now let's say that this is the Earth, and there's an imaginary line going through the middle of it called the Earth's axis. It's tilted, and it stays tilted as the Earth goes around the sun at 100,000 kilometers an hour. That's 1 billion kilometers every year. Now, not only is the Earth going around the sun, but the Earth is spinning. And when you're on the part of the Earth that's toward the sun, it's daytime. And when you're on the part of the Earth that's away from the sun, it's nighttime. Now, the seasons work in kind of the same way. When the part of the Earth that you're on is tilted toward the sun, it's summertime there. So when it's summertime here at Nye Laboratories, on the other side of the world, it's wintertime in places like South America and Australia.
Hey, Bill, your shoe's untied.
Oh, thanks. Then, when the part of the Earth that we're on is tilted away from the sun, it's wintertime here. And it's summertime on the other side of the world. Isn't that wild? All because the Earth's axis is tilted. That's the reason for the seasons. Why are the North and South Poles the coldest places on the Earth? Well, please consider the following. Let's say that this heat lamp is like the sun, because it's hot. And let's say that this globe is like the Earth, because it looks like the Earth. Anyway, we've mounted thermometers on the Earth like this. See? Now, the one at the equator is just about off the scale. And the one at the South Pole is right around the room temperature mark. And the ones in between are somewhere in between. That's because the heat is hitting the one at the equator almost straight on. Whereas at the poles, it's just barely grazing by. And then somewhere in between, well, it's somewhere in between. You see, it's not that the equator is closer to the heat. It's that the heat is hitting it more straight on. See, if the Earth were sitting like this, then this thermometer would be the hottest, and this one would be the coldest. Anyway, that's why the very warmest places on the Earth are right around the equator, tropical rainforests and jungles. And the very coldest places are at the poles, because they're the ones that the energy from the heat lamp just barely grazes by. I mean, the energy from the sun. Well, anyway, thank you for joining me.
All right, so that is good for us here. Any questions on that? All right, so again, the seasons of our planet have everything to do with the tilt of our planet.
Ah, the seasons. It gets
There we go. Everything to do with the tilt of our planet. And as we learned last time, that tilt is off by 23.5 degrees here. Okay, so what I'm going to do is I'm just going to slowly but quickly go through the rest of our slides again, review. I recommend that if you don't understand any of the stuff that we've been going over, please ask me questions, or you can revisit Google Classroom or YouTube also. I have my own channel with all of these recordings on it, so you can revisit if you need be. Okay, questions for me? All right, you guys, then it's time for our first break. So get a snack, stretch out, get up, and let's do this. We got 3 minutes. Recording. Again, sorry. We started with gravity, then we moved to the moon, then we went to Earth, and now we're going to focus on the whole solar system. I want you to work in teams, though. Don't worry, you don't have to talk to each other. I know that makes you happy. But what you need to do is divide and conquer the work, okay? So when we are looking at the actual sheet, let me actually pull it up here real quick. There is quite a few information that you need. And what you're going to end up doing, we're going to have some teams of 4 and some teams of 5. So when you actually have your sheet here, this is going to be a shared doc with the whole team. You are going to make sure if you have 5 people, go ahead and just add the fifth person. You're going to put it in your own unique color. Then now you need is to choose, each member would get 2 planets. So you can pick any 2 planets you want. I suggest first come, first serve. Some students first period were just claiming, I want this one and that one. And if you're in a team of 4, then you also need 2 planets and then 1 to 2 other objects. So if you scroll down here, we have 4 inner planets, we have 4 outer planets, and then we have these other objects, okay? And so we have 1, 2, 3, we have 7 of them. So you would each need to take 1 to 2 of these other categories. Now, all this information is going to be for you right here on nasa.gov's website. Now, nasa.gov's website has a lot of cool stuff in it. So I just want to warn you, because once you get in there, some of you are going to just explore. You want to get this done first. So get your part of the teamwork done first, and then feel free to explore all you want. It's like a rabbit hole. Once you open, you look at this, you can literally get lost in nasa.gov's website. There's a lot of stuff there. Okay. So again, choose a unique color. Use that same color to fill in your section so I can make sure to give you your credit for the day. And divide and conquer. So when you get to your teams, you want to divvy up the actual work. And let's see, let me move some people around a little bit. Okay. And no. All right. Any questions before I let you go? Yeah, use the same color for both planets and what you are doing here. Okay. Let me pause recording.